Thank you, Kelsey. So in this session, we're going to talk about a few key concepts. We'll touch on API management for serverless and multi-cloud. So my name's Prithpal Bhogill. I'll be the co-host of this session for the next 50 minutes, and we'll try and make it interactive and interesting. So I'm part of the Apigee product team. I drive a few different areas for the Apigee team for the core platform. And then I'm also today going to be joined by my partner in crime, Kelsey Hightower, who's going to come in and actually show stuff in action. So just a quick show of hands. How many developers in the audience? Excellent. How about serverless? How many folks working with serverless? OK. And just one last question. How many folks out here are using multiple clouds today? OK, just look around, quite a few. Keep your hands up for a second if you guys can. Look around, OK. Excellent, awesome. So then you come to the right session. So let's start with some housekeeping rules here real quick. So this time at Next, we are doing Q&A a little bit differently. We have a couple of mics here in the middle, so you're more than welcome to line up towards the end of the session for questions. But if not, you can also use the Cloud Next app, click on the Dory Q&A, and ask any questions out there as well. And towards the end of the session, we will just read up those questions and just take our shot at answering it as we go along. Awesome. So let's spend a few minutes talking a little bit about serverless. As I go spend time with many developers, they're adopting serverless at their own pace. But there are key utilities from serverless which make it very attractive. The first one is the aspect of completely abstracting away the underlying infrastructure. So developers love to code, and they want to really just deal with code and say, here's my code, just go make it happen, just go run it for me. Obviously, there's some other business benefits to be ascertained from that as well, such as agility. Because you're working with code as a construct and you are not worrying about infrastructure, assuming a provider can manage that for you, you become more fast at rolling out capabilities which are more differentiated for your business and gain competitive advantage. Productivity is another key aspect of it. Because you can do that faster, you have multiple teams who can collaborate and build capabilities at a much faster pace. So serverless is obviously catching up, as you saw today with a show of hands. A lot of folks are looking at serverless as the next style of architecture in building newer, modern capabilities. And microservices kind of goes hand in hand with serverless in a big way. Usually when folks are refactoring the applications from monolith into smaller microservices, many of them are choosing serverless as a key architecture style to build those applications. And clearly, we have seen a big evolution in serverless. When serverless hit the stage a few years back, it was all about functions, or also known as functions as a service. Clearly, there's been an evolution from functions to building full-blown apps, and now to serverless containers. Of course, Google Cloud has capabilities no matter which serverless flavor you pick. But this brings a very important element of choice, which is no matter what style you pick, you have the abilities in Google Cloud today to be able to leverage the specific flavor and create your application to power some awesome experiences. Just like the internet happened, we believe that developers have a choice. They're going to use various frameworks for very obvious productivity gains. And so trying to control which framework they use doesn't really work out. Because they have a choice, you want to empower developers and make sure they have all the access and controls to be able to use the framework of choice. But of course, as an organization, you also want to be able to put some method, put some control around it so you can manage it very well. But the reality is, developers are using many underlying frameworks, some of these which are mentioned out here, to build new capabilities, but more so are increasingly doing that on different clouds. Just like yourselves, many customers are choosing different clouds for various reasons. It could be diversifying risk. It could be some clouds have some capabilities better than the others, right? What I want to do now is kind of poke a little bit deeper into what we believe are some of the key differences between a service. So at the end of the day, when you're building a serverless application, you are delivering a service. Service is of some value to something, right? So let's say it's a piece of code, a snippet, or the entire runtime, as we just saw, in a container, the other spectrum of the serverless flavor. Let's say you write something in there. Let's pick an example of an ordering system. Okay, so you have a small service that can take orders. Well, that service, that microservice is an architecture style. That's your backend, if you would. That's what you are writing in terms of business logic as your code as a developer. Now, the moment that service gets pushed out to a consumer, so someone who starts to access that service, that becomes an API. So an API is a contract. This is the front end of how a service is usually accessed. In many instances, these two concepts are assumed to be implicitly together. So as an example, when you roll out some piece of serverless capability, of course it has an HTTP endpoint. But there's a clean line of separation, and we'll explain why it is the way it is. As you start to examine how folks are refactoring into newer modern applications, well, it turns out there were legacy applications or monolith applications which existed before. Turns out there were consumers who were still using those applications. So those consumers were still using an API, which is a contract into an application. The difference is now you've kind of migrated over to a new serverless style of building applications. So your backend has really changed. It's very important to understand this difference, semantic difference between a service and an API. And we'll touch on that a little bit more. So why does that matter? At the end of the day, enterprises are building serverless applications to eventually power digital experiences, right? You heard Thomas talk this morning about digital transformation. What does digital transformation really mean? It means that in this day and age, enterprises are building digital products with nothing but APIs. So APIs have become the new mechanism to express capabilities for businesses. And these APIs which power these connected digital experiences, whether that is powering an app that is used by your employees or a third-party partner, or essentially building an ecosystem of different experiences, it are these APIs that really start to take the value that you're building in serverless and make it accessible to consumers. So let's take a step up and see, well, great. I have built some capabilities. How do I really manage this? Turns out, the moment you build some stuff which can easily be accessed, the very first thing you need to start thinking about is security, right? Is this serverless capability that I've built, is it being accessed by someone who really has the rights to access or are authorized to access that capability, right? Can I control it from making sure that it's not abused, right? Of course, serverless is going to give you endless scalability behind the scenes for you, right? But you still want to be able to ensure, what if there's a business quota to it? What if you have signed up for that service and you're really only allowed to use that 1,000 times a minute, right? Because maybe I'm offering a different tier of service, and one partner gets more fair share than the other based on a subscription plan. The other aspect that we get into is, great, how do developers and consumers of serverless, how do they really find out about your serverless applications, right? Is there a mechanism for them to discover them somewhere? And lastly, for the enterprise, it's also about, great, we took this big effort of refactoring our monolith and legacy applications into modern serverless-style apps. How do we know people are using them? Is there adoption? What is my ROI? These are some very hard questions which technical teams have to answer to their businesses because someone is making investment in that. Turns out there is a way to answer these questions. So an API management platform brings a lot of these capabilities out of the box. So you, as enterprises, can continue focusing on building business logic, writing code in serverless-style development paradigms, yet have the peace of mind around how you can use an API management platform like Apigee Edge to be able to control access to your serverless apps, provide the right level of security, also provide the ability for your serverless applications to be discovered easily so that application developers who are consuming your serverless apps can very quickly connect with them, work with them, and then more importantly, as an enterprise, use some key dashboards which give you a sense of adoption metrics, operational metrics, because all those things are very important. Okay? So now let's take a slightly deeper dive into what does API management for serverless actually mean. So today, in this session, we're going to very quickly demonstrate some real-world capabilities using Google Cloud technologies, including Apigee Edge. But let's spend a couple of minutes on this slide. So it turns out when developers take on decomposing a big monolith application, the goal is to be able to separate them out into discrete and independent usable serverless apps or chunks, which means there's always a need to take a bunch of these serverless applications and compose them into something more meaningful. So I spoke very briefly about the connected experiences that you're trying to deliver. Ultimately, whatever you're building with serverless is powering some experience to a consumer. So it turns out there are multiple ways and multiple design patterns that you need to be able to adopt to access these capabilities, which are now scattered across in multiple functions or apps or even containers. So an API gateway, which is part of the API management platform, starts to take a very central role in giving you the tools and widgets to be able to not only protect your serverless applications, but more importantly, take data from several of them, compose them into a higher level experience API, and deliver that. And in doing that, you can use a lot of capabilities from the API management platform, such as ensuring the right level of security, right level of access, and the ability for you to make some transformations over them. Okay? So with that, I would like to invite my partner in crime, Kelsey. Give him a big hand. Okay.
I don't have any slides. Hope that's cool. So this morning you heard about Cloud Run. Anyone use Cloud Run yet? Like one person. Do you work at Google? OK. We have to check. So what I'm going to do is, I'm going to talk about this kind of from the practitioner level. What's happening now, I guess, if you strip away all the buzzwords, serverless, multi-cloud, all the noise, you just have more tools to build whatever you need to build and ship it. So we'll start with Cloud Run. It's kind of this new serverless runtime we have from Google Cloud. My foray into the serverless world, I like the idea of these functions and these code snippets, but there are some times where I just really need to write the app in a way that I'm familiar with. Some of the frameworks help, sometimes it doesn't. So in the case of Cloud Run, I can basically build an app in any language I want, build a Docker container, push it to a registry, and then deploy it. If you've never seen Cloud Run in action, I'll show you a little bit now. So I have a couple of things that we're going to deploy. We're going to step through this one by one. So Cloud Run is really straightforward. You know, what you have here is a very simple application. Let's do this, Control-V, Alt-A. So this is just a Go app. It's really simple. And the goal with this whole serverless paradigm is you're supposed to focus on the business logic, right? So you're not going to have a lot of things like retries. You're not going to do any of your typical things that you would do with Nginx. You're not going to put that here. You're just going to kind of focus on the business logic. Today, my business logic is just reporting the runtime that I'm using, right? I want you to focus on the overall architecture, not necessarily what this app is doing. So when I deployed this container, it's just going to respond Cloud Run. The reason why I like this particular paradigm is I like to be able to develop locally on my laptop using common tools. So if I say go build, what I'm expecting is that I can actually test this particular runtime on my local machine. And if I wanted to, I should be able to hit this with curl using the familiar process that I've been using for years. Most of this stuff is data comes in, data goes out. It shouldn't be that complicated. And you can see here that I hit it with curl, and it says Cloud Run. This could be any runtime, any language. We don't care. It's just going to make some system calls. You're going to get an HTTP request, and you're going to respond. So the way we deploy this is with a Docker file. So if you've used Docker before, a very similar pattern. I don't care what you do in here. You're going to end up with some container image with some entry point. I'm using a two-step build just to make this container super small. There's a lot of people in the serverless community that hear containers and then instantly just like catch fire. I'm like, it's a packaging format, right? You can ship source code, you can ship a binary, and this is just another mechanism for shipping a binary. So if you look here in my two-part build, the only thing I'm shipping is this small binary here, and I'm throwing away everything else, okay? So this just gives me that flexibility of deploying what I want in my own container image. Then you ask yourself, how do I actually deploy this thing? So you can build this thing using Cloud Build. So I don't actually have Docker installed on my laptop anymore these days because I use a tool we call Google or Cloud Build. And what I can do is I can submit my source code and that Docker file, and it will just build it here from my laptop. Or I can use a CI/CD flow, and it will just do it for me. But the idea is we want to make this as simple as possible. Some of our IDE plugins, this will be automated for you. So you hit save, it will do a build. And then how do you deploy it to Cloud Run itself? We also want that to be straightforward. So if you look at my deploy command, that's it. The nice thing about this particular pattern is if you already have a container running on Docker or in Kubernetes, and you want to get rid of the cluster, you want to get rid of the infrastructure, you just run this one command, tell us where the image is, and we'll deploy it and run it for you in that serverless style. We scale to 0, and we scale up on the request when it comes. So when we run this command, what you end up getting is a URL. So we'll click over here. So this is what the Cloud Run URL looks like. We also mentioned in the keynote earlier that in Cloud Run, you can also bring your own Kubernetes cluster. So if you're on-prem, maybe you're already using GKE, you have a collection of workloads, and you just want to use that serverless style, that serverless pattern, you can run these side by side. So you can actually say gcloud deploy to this GKE cluster, and it will show up in the same console. So you can kind of mix and match if you really need access to like a GPU or some specialized hardware that we don't do on the stateless serverless platform here. So here's our thing. It's called runtime. And it comes with the URL and a TLS certificate. You can also map a custom domain to it. But we're just going to keep it really simple. One thing that we've done is you don't necessarily need to use an API gateway day one. You can just hit this particular endpoint. And in my case, this is a private function. So if you authenticate to it, then you'll be charged. If you do not authenticate to this endpoint, you won't be charged, and your function will never be invoked. Okay, so that's an important thing here. So we'll copy and paste this, and they're just going to run curl on my local machine. And we get this 403. And the reason why is that I don't want people hitting this container directly. I actually want to go through some proxy or some gateway, and this is where this Apigee piece comes in. As a developer, what I want to focus on is just that business logic and then deploying my endpoints wherever that may be. So the first thing I'm going to do is say, hey, instead of me configuring authentication here in my app, we're just going to delegate that to Apigee. Now, last year, and I'm pretty new to Apigee myself, so last year I built a bunch of hacks to create OAuth tokens to store in Apigee's key value store and then tell Apigee to pull it out, put it in the header, and call my code. I was like, this is terrible. I called the Apigee team. It's like, there's no way we work at the same company and I have to do these kind of workarounds. So they built some extensions for me. I was like, let me see them. Do they work? That's you always ask your product team, does it work? They always say yeah for some reason. So to think about this is there's a new set of things called extensions. And what you do is you find one of the extensions. So in this case, I want basically our Google Auth extension. And what the Google Auth extension does is the Google Auth extension will allow me to use an OAuth token or mint one for me automatically. Let me go through this. Let's see this, auth. So here I just called it Cloud Run, but it's using the Google Authentication extension. And what this does is I can configure this particular extension with a service account and tell it what it's going to be used for. So if you click here, you'll be given the ability to configure this and deploy it to one of your Apigee environments. So I basically have a set of credentials that we don't show you on the screen. I'm glad, because that would be bad. And then basically at this point, this particular extension, using that service account, can then be referenced when I create a proxy. So if you're new to Apigee, like I am, I'm going to walk you through a little bit of what this means. So the first step is we use this extension. It will start to create OAuth tokens for me automatically behind the scenes. And I also have to give access in IAM that it can actually invoke certain functions or Cloud Run instances. So it's not going to be able to call anything out of the box. You still have IAM control over what it can and can't do. Now, in the Apigee space, we have to create these proxies. So the first one we're going to create is this Cloud Run proxy. And this is enterprise stuff. So we're using XML for configuration. I guess that makes it enterprise ready. So you see all this XML. Don't die. I almost did. I had to come back to life. So the first thing here is this extension. So the nice thing, though, is there is a UI composer. You don't really have to write all the XML by hand. So if you click on this composer, you can start to configure some of these things. So these things were set up ahead of time. Let me close this out. And what you'll see here is the configuration for this extension. I'm saying I would like to use the Google Cloud Run extension using the Google Authentication backend. And then you give it a couple of things. So I know from the documentation, in order to call a Cloud Run service, I have to give it this particular audience. So I know behind the scenes, the extension is going to use the Google API, mint the OAuth token, using that particular audience, and then it's going to have the ability to make that credential available in this output string. Right? So if you can see here, we have this output string, and this allows me to then compose a call that will extract that out and set it into the header. And I'm going to show you that configuration really quickly, and then we're going to invoke this. So what I'm saying now in this particular extension is I want to set in header before you actually call my app. So you can actually see this visual request preset of steps. I can go to the authorization header, reference that Google Cloud Run credential, and it's going to inject it in the header for me automatically, okay? So the nice thing is, so this is the thing that makes Apigee dope in my opinion, this whole little trace thing. I was like, I can do that with Nginx. Why are you showing me this right now? And then he did this. He clicked on the start trace thing, and you can actually see this complex configuration like come to life. So if I hit this, you can see that it's going to actually move through each of those steps, and it's going to invoke my particular function. So you see here, I'm going to walk through what the output is. It goes out to the extension. I'm going to show you some credentials. Don't be hacking my service while I'm on stage, okay? Wait till later. If you're on YouTube, this won't work at this point. It's expired by the time you watch this. All right, so down here, let's see if I can make this a little bit bigger. So down here, we're going to have a bit of response stuff happening here. So this is actually going to, note small to read here, it's going to create that OAuth token, and it's going to store it in a way that I can reference it here when I set the header. Let's move this back some. Can I collapse this? There we go. All right. We should really make that, all right, so there we go. So we have this access token. So that access token is going to be extracted out, put it into a header, and it's going to be used to call the service underneath. And then you can see here that it's going to respond Cloud Run, just like on my local laptop. So if I grab this, now hitting the Apigee endpoint, we can see that we hit our particular backend, okay? So then what makes Apigee relevant to having multiple applications? So let's try something with Cloud Functions. So this is using Cloud Run, but we also want to deploy something to Cloud Functions. So if you never use Cloud Functions, this is a different take on this whole serverless thing. This is more of a function as a service. And Cloud Functions, you write code that looks like this. So you get rid of all the server initialization, and you just write your handler. So this is also Golang. You just write a normal Go HTTP handler. You'll get your request automatically. And just like Cloud Run, we also give you an HTTP endpoint you can hit without setting up an API gateway. But in this case, I also want to make this also a private function. Now, this is deployed using a different thing. You don't build a container first. Here, you just use a deploy command, and it looks like this. So I'm going to just be in my source directory. I'm going to configure this particular thing to run as a specific service account. And if you look down here, I'm going to grant the Apigee service account the ability to invoke this function. All right? So that's critical. So the nice thing, too, about Apigee extensions, we also have an extension just for Cloud Functions. So all you have to do is give it the particular set of credentials, and you tell it the function that you want to have it invoked, and you can skip a lot of the boilerplate that I did a little bit earlier. But here's where I think Apigee gets super powerful, right? The other thing you might want to do with APIs is each of them will have some response. Clients will hit your endpoint. You'll respond however you want. But there are cases where I see people that are refactoring. Maybe it's a monolith, and you want to add a v2 endpoint. In that case, sometimes I'll build a small function that adds a little bit, and we can enhance the particular response. What you can do in Apigee is I can actually compose the response before it goes back to the client. So think about it this way. I can deploy a Cloud Function. It's going to have its own response. I can take both of those responses and munge them into their own output before I send it back to the client. So let me walk you through that configuration really quickly. So we have another API proxy, and this one's going to be called Mashup. So the endpoint here is going to be this Cloud Function Mashup. Then what we're going to do here is just going to look at the deploy step, and I have a bunch of these steps that have been put in here. So very similar to the beginning, we're going to use the extension to grab the authentication to call my first service on Cloud Run, and it's going to respond with its runtime. And then we're going to hit the Lambda runtime, or not Lambda runtime, the Cloud Functions runtime. And that extension is going to call out to Cloud Functions. And here I'm just going to tell it what region, the name of the function is also called runtime. And then I'm going to take the response, and I'm going to show you the configuration here. So in this configuration, you can see that I'm going to be able to reference the response from the 2 invocations previous. So when I call Cloud Run, I'm going to take that output. When I call Cloud Functions, I'm going to take that output. And here, instead of returning a raw string to the client, I'm going to return this JSON payload that I'm composing here without writing any additional code or hitting any other backend. So what should happen here is if I were to hit this endpoint, so we'll go over here to the overview. If I were to hit this endpoint, this mashup endpoint, what we should see is both of those functions being called one by one, and we should compose the response with both of their runtimes. So you can see that there now. So even with the cold starts, you can see the cold starts are pretty fast on both Cloud Run and Cloud Functions. And now Apigee is composing the response from both of those independent serverless calls into something that I want to do for the end user. So this gives me the ability to compose and do whatever I want without additional code. Now there's one more thing that we wanted to show you, like where's the multi-cloud piece? I typically don't say things like multi-cloud. There's like multiple environments where you want to do some computation. The hard parts about multi-cloud or multiple environments or multiple cloud providers is composing the network layer and the storage layer. So what we see people do is they'll just use best of breed. So if you're using Amazon, maybe you have a lot of data in DynamoDB, you're probably just going to use Lambda. If you have some stuff inside of Google Cloud or Cloud Storage, you're probably just going to use Cloud Run or Cloud Functions. We're not forcing you to choose. So we've also built an extension for Lambda, very similar to the other extensions that I had before. When you write your Lambda code, if you've not written any Lambda, good for you. You're probably only using Google services. That's what we want you to do. But in the Lambda world, here's another Go app, very similar. You write a function main, you give it a handler, and it's going to respond. Now, the response is a little bit different in the Lambda world, and you'll see when I munge them all together. But what we want Apigee to do is also compose this multiple cloud thing for us. So Apigee is our central control plane. It's our central entry point for all of our clients. But it has the ability to go out to all the other endpoints and aggregate all the responses. So this is what we mean by API management. We don't have to leak all of these details to our end users. If you're in the organization and some people want to use one cloud provider, another team wants to use a different cloud provider, you don't have to argue too much. You can normalize that stuff on the edge. So we go over here to Lambda. I'm going to show you that I actually have it deployed to Amazon's Lambda. This is a standard. It's also called runtime. And then what we do is we're going to show you the last piece here in Apigee, where we'll go to a different proxy. Now, I could have done this all in one single proxy, but I broke it up so you can actually see the steps. This particular path is called MultiCloud. So if I click on MultiCloud, you'll see the various callouts that I'm doing here. So I'm going to show you that configuration here. And you'll see, hey, don't be giving me any errors in front of folks. So the first one here, I'm calling out to that cloud function like we had before. Then here, we're going to be calling out to the Lambda using the Lambda extension. And the nice thing about this Lambda extension, just like I set up before with Cloud Run, I just give it a set of credentials. So you go to Amazon, you create a set of credentials that give it limited access to invoke the Lambda function. You don't need anything else. And then I can refer to that extension here and tell it very simply, the name of the function is runtime. This is going to be a synchronous request response. And then I'm going to take that response that comes back from Lambda and hold it in this variable. And again, just like I did with Cloud Functions, I can take that variable and then use it as part of that pipeline to munch the response. So the only thing I'm doing here is taking that response. Oh, scroll up. I'm taking that response, and I'm adding the Lambda response to it. So we should see an additional response in our particular array. All right, so let's go ahead and hit this endpoint to verify that everything works. So we'll click on this overview here. And then we'll grab this endpoint to see if all three can be invoked, and we should get that munge response. So we'll click here, and we'll go back to our browser. So you see that there's two there now. We'll hit the MultiCloud endpoint. And you can see now we've added the response that comes back from Amazon Lambda as well, using Apigee to sit on top of all of those, and it gives you choice between any cloud provider, any serverless stack that you would like to use. And with that, I'd like to end the particular demo. Thank you.
Thanks, Kelsey. That was awesome. You guys think? Awesome. So what you saw Kelsey take us through was something very powerful. He mentioned a few key capabilities that we built around what we call as Apigee extensions, which give you the ability to access many cloud services, of course, from Google Cloud's platform, and also from other cloud providers as well. So the Apigee API management platform is a full lifecycle API platform, which is a key component when you start building your serverless applications to ensure that they are accessed securely, they have the right level of controls in place, and you have right level of operational visibility into it. So if you start looking at the different layers of the platform, it starts with the API runtime. What Kelsey was demonstrating today was the core enterprise gateway and a set of out-of-the-box policies which make it very easy to take data from different kinds of serverless apps, do some composition, as you just saw. The next level up is known as the mediation engine, and that provides some of the core capabilities around taking and orchestrating data from different sources. In this case, in particular, Kelsey demonstrated 3 different types of extensions. So 2 of the extensions were actually just announced today at this session, the Google Authentication extension and the Cloud Functions extensions, which became available generally today. So those extensions were a perfect example of how you can take capabilities from different serverless apps, compose them. Well, he took it a step further. He also showcased the Lambda extension, which is available within Apigee as well, which you can use to go access your serverless capability that you're building on AWS. As you go higher up in the stack, some area we didn't cover today, and I'll show some screenshots real quick, is the API monitoring and analytics capabilities. They become very important in the realm of once you have an API program which is thriving, and many of your consumers are using APIs, you want to be able to ensure you have the right level of visibility, not only from an operational perspective, of course, taking care of things like, are my APIs performing well? Are they, do they have a lot of errors suddenly? Those kind of things. To business metrics around adoption, right? I spoke about, great, you're building serverless applications. Who's using them, right? Do you have the right level of metrics on adoption? And if not, some corrective actions could be taken. And the developer ecosystem really touches on the next level of how do I really get the developers access to these kind of applications, which are nothing but API endpoints at some point in time. So I'll just walk you through a couple of slides here real quick. So this is an example of the developer portal, which is a key part of the API management platform. Using the constructs available here, some of the API endpoints that Kelsey was demonstrating, we can very quickly and automatically generate API documentation, which can be rendered on a developer portal that any of the application developers who are the consumers of the serverless capability that you're building can very quickly access. They can try them out, and more importantly, they can register to start using those capabilities. So developer portal becomes a key entry point for the consumers of your serverless applications. And then last, I'll kind of touch a little bit on the consumption aspect of it and monitoring and analytics. So these dashboards give you a very high-level entry point into the different kinds of metrics the API platform captures out of the box. So just as you saw Kelsey walking us through 3 different API proxies, the moment API traffic starts to pipe through those API proxies, we collect over 200 different data points and have aggregations of data sets which can be accessed over APIs or also accessed through the UI, which Kelsey showed some parts of it today. Right? So one example is the dashboard on the top left, which shows you the overall engagement, the overall traffic pattern. Right? What kind of API calls are being made, how many of them are in error, so on and so forth. And then you start to see some other aspects of performance, latency analysis, and then the ability to do custom reporting. Right? So if none of the 20 or so out-of-the-box dashboards are enough, you can actually go build your own custom reports. And this is a very important feature because many times, APIs, once they become front and center of how you serve data, there are different stakeholders within the API program, such as line of businesses. If you're building an order API, they want to be able to know, well, how many orders are passing through of a specific amount for a specific region, right? You don't have to go out of the platform. You can use the custom report to be able to just quickly whip up that report and give it to the specific line of business stakeholder who wants it, versus having to rely on getting data out using yet another platform to build that out. Okay? So with that, let's kind of have Kelsey back over here. Let's kind of summarize some of the key takeaways, and then we'll take any questions after this. So if you want to come on over, Kelsey. So just 3 high-level key takeaways. I think we went through a lot of things today, but very quickly we spoke about some of the serverless capabilities that many of our customers are adopting. So clearly, it's very popular. Do you want to talk a little bit about multi-cloud and your experience?
Yeah, so I think for me is the serverless piece is probably not going to be one provider platform specific. I look at them as ways to program in the cloud. Sometimes you're responding to events. Something got uploaded to a bucket. Sometimes you just have a business logic that you've had for years, and you just want to deploy it via a container. And I decouple the problem. So as much as I like these fully integrated platforms, I do like the ability to compose, right? I have a Unix background. I would like to use an API gateway for a certain thing. I want to use different runtimes for different things. And what we talked about today is the ability to compose. What you saw in my demo also is that I didn't have to use Amazon's API gateway. I didn't have to use a load balancer in GCP. And I was able to pick and choose how I want to orchestrate my particular stack.
Perfect. And then last but not the least, as you hopefully would have realized today, API management is a very vital function. When you're building serverless applications, the moment you expand the reach of those serverless applications to your consumers, you want to ensure they're secured. Only the right level of authorization is allowed in terms of access. You want to have the right visibility. So API management becomes a very critical function as you start to roll out more and more serverless applications.